this video, we're gonna see the kinetic energy of an orbit. So yes, I am drawing here one, you can say, orbit. This one I have the orbit, and as you can see, we can say here we have positive charge. So here you can see electron revolve around the nucleus, and electron passes what? Electron passes kinetic energy. So today we are going to calculate this kinetic energy between two masses. As you can see, this is the what charge and electron kinetic energy between two masses, which can be gravitational and electrostatic. So first of all, as we all are familiar with that, the formula of kinetic energy is, that is, kinetic energy is equal to half mv square. Okay, so as kinetic energy is equal to half m, and in the last video we have found out the velocity, and the velocity was basically the velocity which we found, that was z square, and we were having 2 epsilon h n whole square. So this is the velocity which we have find out in the last video. Fine. After that, here we are going to solve it again. Here kinetic energy is equal to 1 upon 2. Here it will be m z square and e 4, 2 to the 4. Then in the divide form we have what? 2 to the 4 epsilon square h square and then a square. Why I have given the square? Because whole bracket we have a square, so we have contributed the square to every single equation. After that, here we have what? Kinetic energy is equal to 1 upon 8, because 4 to the 8. This will be m z square e4, and here we have epsilon square h square and n square. Fine. Then we have kinetic energy is equal to m, you can see e4. Okay, and here we have what? Here we are going to, you can say, separate the constant and variables on the one side. So as you can see, the one which I'm going to separate here right now, so those are the constant. As we have know the mass value, we know the charge value, so these are constant. And if I do talk about the variables, so those will be z square, because z square changes atomic number, and we have n square. Okay, so this is how we have separated. So you can see, when you're gonna put the values of these all constant, we will get what? 1.13.6 into z square and n square electron volt. So this is the kinetic energy of an orbit. Okay, these are what? These are variables. I hope so that it is clear to you how I have calculated the kinetic energy of the electron. So now we are going with the potential energy of an electron. Energy. Now I'm going to move in with the potential energy. So as you can see, potential energy is basically what? Energy between two charges. Here we have Q1 charge and here we have Q2 charge. Two charges. Here we have, you know that between two charges we have electrostatic potential energy, right? As we all are familiar between that. Between two charges we have electrostatic potential energy. So the formula of potential energy is V is equal to 1 upon 4 pi epsilon into charges Q1, Q2 over R square. Fine. After that, potential energy is equal to 1 by 4 pi epsilon. Now here you can see, for the charges we have got two electron charges, one charge and two charge, and this is what charges are, basically the atomic number. So we're gonna put the z and divide by radius, so R square. Fine. After that, here we have potential energy is equal to 1 by 4 pi epsilon is equal to, this will be z e square, divide by, we have what? Here we're gonna put the value of radius. So as in the previous video we have calculated the value of radius, so here I can denote the radius value as, denote that, yep, r is equal to, that is 0 point, sorry, r is equal to and square h square epsilon divided by pi m ze square. So this is what? This is the value of radius. So we're gonna put this value in this equation here. So r, here we have, for divide form we have pi m Z square into this one upper one we're gonna put here, that is N square H square and epsilon. Okay, I have told that it is sorry, that is cancel with pi, so that will be N square H square epsilon into pi M Z square. Here we have taken the reciprocal. So as you can see, pi is cancelled with pi and epsilon is cancelled with epsilon. Fine, so the remaining will be M Z square Z1 and 1 Z here Z square and E 4. Then in the denominator we have 4 and we have, so this is not cutted, here we have epsilon square and N square and H square. Fine, I hope that it is clear to you guys. Now here we're gonna multiply this whole term by 2. Multiply by 2. So when you're gonna multiply this whole term by 2, what you will get basically M Z square E4 divided by 4 to the 8 epsilon square H square and N square. Fine. So then we have what? So we're gonna separate this, multiply by 2. Fine. So this is, we're gonna separate this. This will be M E4 and 8 epsilon square H square. This is what this whole value is constant, and into Z square upon N square. Electron volt, this is variable. Fine. So the we have our total potential energy is, this will be 2 here, we have minus 2 into this whole term is, we're gonna put the value and we will get 13.6 into Z square N square. So this is, we have the potential energy. So the main difference between kinetic energy and potential energy is, here we have only 2 and here we do not have any 2. So after that it is clear to you guys. Now we're going to discuss about the total energy. So let's see the total energy. Okay, so here I'm going to find out the total energy. For finding total energy, as you can see, total energy is equal to sum of kinetic energy and potential energy. As we have discussed in our previous classes, total energy is sum of kinetic energy and potential energy. So the kinetic energy which we have gotten, that is 13.6 into Z square N square, plus the potential energy which we have gotten, that is minus 2 into 13.46 into Z square divided by N square. Fine, so total energy will be what? Sum of kinetic energy, potential energy. This will be minus 13.6 into Z square N square. So after that it is clear to you guys. Fine. So now let's see, we're gonna find one question we're gonna solve. Here I'm going to give you one question. Okay, so question is basically total energy of E electron in nth shell of hydrogen atom. We have to calculate the total energy of electron in nth shell of hydrogen atom. Find nth shell of hydrogen atom. So here you can see total energy is basically minus 13.6 into the, we can say, atomic number of hydrogen is 1, so 1 is square, and we have to find out the electron from nth orbit, nth first orbit, and square is equal to minus 1 minus 1.36. So this is the same. So if I talk about the electron energy from the second orbit, so that will be 13.6 into atomic number same 1 square from second order, we can say second shell, so that will be 2, and it will be 3.14, so minus 3.14 electron volt. Okay, so if I talk about the third orbit, so that will be 13.6 into 1 whole square upon 3 whole square, it will be 1.51 electron volt. Okay, so when you talk about the fifth orbit, fourth orbit, so that will be 0.85 electron volt. So this is how you can see there's an increase in numbers. You have 13, minus 3, minus 1, and here 0. So this is in the increasing order. So if I do make here the shell, now we have first of all here we have nucleus. If we have another shell, this is another shell. This is fourth. Fine. So as you can see, this is the first shell on which the energy is what? On the first shell, energy is minus 13.6. Okay, so this is the minimum energy. So going down, the energy is increasing. This is minimum. Fine. And if I do talk about the second shell, the second shell energy is what? Second shell energy is minus 3.4. And third shell energy is 1.51. And fourth energy we have 0.86. So how you can see this is the increasing order. Okay. So till if I talk about nth, so it will be infinity. So total energy will be 0. And total energy will be 0. This means ionization has occurred. Ionization ionization has occurred. Okay, so if we should do one more question, so let's solve one more question here. Question. In this we said K electron can accept energy and can lose energy. Sorry. Here we have what? Yep. If we have what? Electron plus change in energy will be equal to E2. And here you can see electron 1 plus change in energy is equal to electron 3. So this means how we're going to take out the final energy. First of all, if from the first shell I have to find out the second shell energy, so I'm going to do what? 3.6. I'm going to add what? 10.2, so it will be minus 3.4. This is the energy of second shell. For example, if I have what? 3.6, the first shell plus I'm going to add this 9, it will be 14.5. So you can see we have here 14.5, and in the shell there's no any 14.5. So this means only the orbitals will be present on this energy, not on the mid of the shells. Okay, so this means it won't be possible. 14.5 will be not possible. So I till that it is clear to everyone. So in the next video, we're going to discuss about some more important topic. Till that, bye-bye.